let's start. Who am I? My name is Juan. And normally from 9 to 6, they call me a software engineer big data at Lobu, which is a dating app in Germany. However, today I would like to scratch this title, and I want to be a Pokemon data master. Why is that? Well, because in today's presentation, which is titled Detecting Pikachu on Android and More, using TensorFlow Object Detection, I'm going to be talking about Pokemon and data. So please enjoy, relax. It's a really cool presentation, so enjoy. So now, first question, and please do not disappoint me. What is this? No answers yet. What is this? Exactly, perfect. So, Pikachu, yellow mouse, red cheeks, we love it. However, what about computers? They do not know what is a Pikachu, right? If I go now to my computer and I'm like, hey, what is this? It's not gonna say anything because computers do not talk. So they are pretty ignorant about Pikachus, and this makes me unhappy because we know what is Pikachu, and computers and devices, they do not know. So my goal here with this experiment is this. I want to close this gap of ignorance. I want to teach computers what a Pikachu is. But before I start, since this is about Pikachu and object detection, let's take a small example. That's Pikachu, right? And that's a really nice green box, meaning that this is indeed one Pikachu. So this is my agenda for today. I'm going to divide this presentation into three main parts. First, I'm going to be talking a bit about theory because it's always nice to know what's going on under the hood. Then also, I'm going to explain you guys how I build my own custom detection system for Pikachu. And then, even cooler, how I am using this model. So let's start now. What is object detection? Well, I like to define object detection as the process of recognizing instances of an object in images or video in any frame. However, I'm really sure that maybe some of you, maybe back there, is asking, hey Juan, what is the difference between object detection and image classification? And that's a really, really nice question, my dear friend. And the answer is this, or my own answer. So here we have two images, right? Normal Pikachu and the object detection. Let's suppose that we have the best Pokédex. We have the best Pokemon detection classifier, classification, sorry. Like we feed one image and the output is going to be Pikachu, right? Really straightforward. X, image, Y, Pikachu. However, in object detection, the goal is more granular. Here we want to know something even more than just knowing that it's a Pikachu. Here I want to know exactly where my Pikachu is located. And this is nice because maybe you have the use case of you want to know the relation of this object from the other one. For example, is Pikachu on top, below, beside this? Also, maybe we want to know how many Pikachus I have. And here we can see that we have like two different labels. Pikachu, Pikachu. Indeed, two Pikachus, 1 and 2, perfect. However, on the other image, let's suppose that we have 1,000 Pikachu. The output is still going to be Pikachu, right? But we won't know exactly how many Pikachus I have. So that's the main difference. Here is more granular, it's more specific, and here is just like, yes, that's a Pikachu. And it's the same what I just said. And how did I build this? Like, how did I did my system? And I use TensorFlow Object Detection API, which is TensorFlow's answer to the detection problem. And this library is really, really cool. And the best part is that it is able to trade accuracy for speed and memory consumption, meaning that we are able to make our system a little bit more weak in terms of accuracy. However, it's going to be even better in terms of speed and memory consumption, meaning that we will be able to deploy it in weak devices, such as mobiles. And why is this? Well, this is due to the fact that the package includes many feature extractors, and architectures, and we're able to play around with them. We can choose this architecture or we can use this extractor, and we keep playing around with them. We might be able to find the right balance between speed and accuracy. So now, let's start. Get some paper, because maybe some of you want to take some notes, and let's talk about how I build my own detection system. First, of course, we need to install TensorFlow. I'm really sure that most of you already have it. But more than that, we also need to clone the repo called models, meaning that we have to go into TensorFlow GitHub. You have to look for the repo called models, and you're going to clone that one. Straightforward, right? But next, we need to create our data set. So simply just guess a bunch of images. I use around 230, and 80% of them were used for training, and the remainder 20% were used to evaluate. And I try to be as diverse as possible. Try using Pikachus from the cars, from the anime, from different seasons of the anime, fan art, and so on. Also, I try to get different positions of Pikachu. But let's be honest, Pikachu is a fake yellow mouse, so every time someone is going to draw it, it's going to focus on the knife. Hey, perfect. Is it working? Nope. Yeah, perfect, okay. So as I was saying, every single time someone is going to draw Pikachu, it's going to focus on the main features, which are the red cheeks, the tail, and the ears. So it was quite hard to get other angles of my dear Pikachu. So after that, we have to label our data set. And the process of labeling here is quite different than what we are used to. Why? Because here we're dealing with object detection. So we need to tell our system, hey, this is my object. And the main idea here, using one of the many software that are available for doing this, is that you're going to draw a bounding box surrounding your Pikachu. And this takes a lot of time. It's really boring. You have to take your mouse, load the image, draw, click, and then you need to write the name Pikachu. So please, just do some Netflix and chill, Spotify and chill, because you're going to need it, because this is really, really boring. So every time you label one image, this is going to output an XML file, which is going to contain the name of your image, the name of your object, and the coordinate of your object, which in this case is this tiny box that we have here. But TensorFlow, it does not deal with XML. TensorFlow is like, hey, the heck is this? I don't like XMLs. So we need to transform this into a format that TensorFlow knows. And this one is called TF record. And the repo, it already contains all the code, the script that you need to do this. You simply need to specify where are your XML, and this is going to output one nice file called TF record. And I have this script also in my GitHub. I'm going to present the link at the very end. So every time I talk about script or code, believe me, it's going to be on GitHub. So don't worry about that. Then there's something else that we need, and this is called the label map. And the label map is simply one really tiny file that contains the ID of your item and the name of your object. In this case, my ID is #1 and my object is Pikachu. Please keep in mind, do not use ID 0 because that number is reserved. So far, let me breathe a bit. So I talk about how to install TensorFlow and what exactly we need. I talk about how we have to create the dataset and how to label the dataset, followed by creating the TF record file and the label map. Now let's move on to something more interesting. How do we train this? Because this is the good part. So the training here is based on one amazing file. It's called, let's call it the pipeline. And in the pipeline, you specify everything regarding your training. Now, this file, it is divided into 5 different sections. The first one of them is called model. And in model, we're going to specify the architecture, which is my object detection architecture that I would like to use. We also specify the feature extractor and the loss function. Then we have training config. And in training config, we are going to write about the number of epochs that we want to use for our training, the size of my batch, and the training checkpoint. Then we have the train input reader and evaluation input reader. And here we specify where is our training set and our evaluation set. And lastly, there is eval config. And here we're going to write the number of examples that we want to use to evaluate our model. Now, this file here looks quite simple, but in reality, it's really, really complex. Mine is made out of 180 images. However, TensorFlow, they're such a nice guy. So they already provide us with a huge list of example config files that we can use. So we don't have to spend hours and days just like tweaking all these little numbers like training, whatever, like delta and alpha, all these small things that we use for neural network. We don't have to do this. They already did it for us. So instead of spending hours doing this, just go there, just find one, and just play around with it. So now, how do we run this? Well, there is another script in the repo. It's called train.py, and we're simply going to call this script, and we're going to use as a parameter the path to my training directory, which is the directory where you have the TF record and the label map, and then you also need to specify where is your pipeline file. But now, before moving on and start talking about this and continue talking about this, I would like to make a small stop and talk about which architecture I am using, because like I said, theory is a bit nice. So the architecture I use is called SSD, which stands for single shot detection. And it is called single shot detection because it's going to predict the class of my object and its location during the same shot. The opposite of this is an architecture that requires a second component named the proposal generator to predict the position of the box. And this is an image from the official paper that describes the library. And here we have three different architectures: SSD, faster RCNN, and RFCN. And we can see that here, there's only one box after the feature extractor, because everything is going to be performed in one single shot, while the others two, they have like two different boxes. I know it's quite hard to grasp the concept, so if you guys are more interested in this is the name of the paper. It's really amazing and awesome. I have a copy somewhere, so if someone wants to take a look, feel free to ask me. But now, let's move on. How do I evaluate this? I'm training. How do I know if my model is going to be an amazing one or a really boring and shitty one? So they already provide another script called evaluation.python. And when you execute this script, this is going to calculate a lot of different metrics regarding your model. And the one I use personally is called the total loss because it's obvious. It's always nice to see the loss. And also one use Pascal VOC MAP, mean average precision. However, how do we see this? It's like, yeah, we're calculating all of this, but we want to see them, right? So some of you might know that TensorFlow has a component called TensorBoard, which is its web UI, which can be used for a lot of different reasons. And it is also available for this project. We can see TensorBoard to see the performance of the model. And this is an example of how it looks like. There is like 1,000 of buttons, pretty graph, and so on. So just feel free to play around with it. But even better is that we can see the process of our training right here in TensorBoard, meaning that we are able to see the detections right there. And even cooler, here there's a slider. And this slider is going to move through every single checkpoint of my training. So we can evaluate our training, for example, in epoch 1000, in epoch 2087. So, and it's really nice because when you start from the first one, normally you don't have any boxes, but you can see how the boxes are going to like, pop, to show up. Meaning that your model and your training is indeed working. And how do we run this? Really simple. We run this evaluate.python, and we use the same parameter that we used before. We have to repeat some of them, like training directory and checkpoint directory. They're normally the same one. And how do we run TensorBoard? Well, we just call TensorBoard, and then we send as a parameter the path to my training directory. So now, training is over. It's nice. Woohoo, we are happy with it. But now what? We need to freeze this model. We want to use it. So during every single checkpoint, TensorFlow is going to create 3 files, and they end in the extension .data.index.meta. But this is a lot of information. Like, I don't want 3 files in my pocket. I just want 1. So for this, we have to freeze our model. And they already provide one file called export inference graph. And when we call this file, we're going to specify which is the number of my checkpoint that I want to use. This is what I have here, this x, 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 x. So we're going to write the checkpoint that we want to freeze. And then after this, you're going to have one file called frozen inference graph. And this, my friends, this is what you want. This is what you want to keep in your USB, in Google Drive, Dropbox, or send it to your mom. This is our model, so please take care of it. But now, let me take another small break to breathe. I think I'm going quite fast, so I'm going to slow down. So far, I have talked about how to train our system. The whole pipeline file, we specify the model and so on. Then I talk about the architecture I'm using, SSD or single shot detection. Then how do we evaluate our model? Followed by this, how to freeze our model. But now the cool part, how do we use this? So I have my model, it's perfect. I want to impress my friends. I want to impress all of you guys. So the first use case that I tried was a really simple one, images, right? And in the repo, there's already a Python notebook, which has most of the code that we need for this, again. And the only thing you need to change, let's say, are some really specific, like where is your frozen model? What is the threshold, the confidence threshold that you would like to use? Also, maybe you want to change the color of the box. Maybe you don't like green, you want it yellow, but because it's yellow, so that's not a good decision, and so on. And this is an example of how the code looks like. I'm not expecting you guys to see this really far, but just to give a small idea of what's going on here. So first, of course, we need to load our image. Then we need to convert our image into an array representation using NumPy. Then we're going to run the TensorFlow section on this. And this is going to return three main things. The one is the box, if there's one box. What is the coordinate on my detection box? Followed by this, we have the score. What is my confidence score? How sure I am that this is indeed one Pikachu and not one yellow blob? Also the class. What is my class? Is Pikachu or is it 0? It's null, it's nothing. Then we call this function called visualize boxes and label on image array using this parameter. And this is the result. Detection boxes and Pikachus. Here we can see 5 different Pikachus. We can see that the one in the middle is a false negative because indeed that's a Pikachu. But like I mentioned earlier, I couldn't find so many images of weird angles of Pikachu, and in such cases, it's not going to get detected. But we can see in this case, I really like this one because we see Pikachu with 2 Pichus. And I think the prediction, in my opinion, is really clean because the box is right where it should be. It's not getting so much of the Pichu, and the worst case scenario would have been a detection of the whole image. And here we can see Pikachu sleeping, Pikachu happy, and teenage Pikachu. So now, on Android. So how do we do this on Android? So first, of course, we need to get the Android demo project from TensorFlow. So please, now we need to clone the TensorFlow repo, not the models one, the one from the official TensorFlow one. And somewhere there, there's a directory called Android. This is what we need. Also, we're going to need Android Studio. So get ready to install another IDE in your computer. So now we need to import the project. So we're going to Android Studio, importing the project, and we're going to select the directory I mentioned 27 seconds ago. This one, Android, remember. And here in overall, our goal is going to be to install the demo app. However, there's some changes that we want to do to the actual Java code. We want to specify where is our model once again, and then maybe we want to change the confidence threshold. So we need to play around with it a tiny bit. Also, we need to build and compile our project. I'm not sure if some of you know about Android, but normally you do this using Gradle. They already provide the Gradle file. You only need to click the green hammer button and it's going to build. However, by default, at least when I did it, there is one variable called native build system, and by default, it is set to none. If you keep it by none, the project is going to run, but you won't get the dependency. So maybe your app is going to crash. So please make sure that you use any of the other options that are already provided for building the project, which are Bazel, Makefile, or CMake. And then everything's ready. We build the project. Let's make the magic happen. So we go into this really cool bar. We click the green play button. And if we are lucky, please, by the way, make sure your device is connected, really important. And if we are lucky, we're going to have a nice app running. However, I was not that lucky. Tan, tan, tan. 3 seconds of silence. Errors, errors, errors. Angry faces, and you have no idea how many bad words I said. This, my dear friends, 6 weeks of looking at this. And as far as I could understood what this means, all this blah, 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 is that there is one operation or one node in my frozen model that is not available on the Android side. What? I was like, what? So I tried a lot of things. First, of course, I make sure that it's the same version, even the same commit version for on my project, and didn't work. I went to GitHub, I did an issue, nothing. A lot of people commented, yeah, I had the same problem, blah, blah, blah. No solution. So I overflowed the same. 6 weeks, I was like, Jesus Christ, it was almost like Christmas. I was home, drinking piña coladas, and just thinking about Pikachus and this. And it was really frustrating. I was about just like to throw everything away and that's it. But then one day after the piña colada, I went home, I went to the code, and I took a look at the file, the script I used for freezing the model. Because to be honest, since they already provide the file, the script, you don't have to write anything. So you just run it and that's it. And deep inside, so deep inside the code, there is one function. I don't even remember the name. And it has this variable. It's called optimize graph. And by default, it's set to true. And I was like, I don't want to optimize anything, I was really angry that day. I do not want to optimize. I want the model raw, the way it should be, the way TensorFlow did it, raw, without optimization. So I just went to the variable, I put my mouse on the word true. I did backspace, 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 backspace 4 times because true is 4 letters. And then I wrote F-A-L-S-E, false. Then I froze my model. I took it again. I went to Android. And guess what happened? It worked. Today, I still have no clue what that happened. I'm not smart enough to know exactly why, but please do not optimize your model, okay? Because it's not gonna work on Android. And this is how it looks. Look how beautiful it looks. This is my app. This is a Pokemon card I have here on the back of my phone. It's my example for always impressing my friends. And we can see that detection is quite cool. Here we have another screenshot, and we have 5 detections at the same time. This one, it wasn't detected, but come on, I got like 5 out of 6. I think it's nice. So it worked. It's nice. But however, let's be honest. I'll be really honest with you because I like you guys. I was not so happy, you know. I was not so happy. I was like, it's cool, but I feel like it could be better, you know. I feel like the Android side was kind of weak. There was a lot of false positive. Pikachu not detected. It was really slow. So I was expecting something more. I was not proud of myself. So I decided to improve a tiny bit my project. So I added 70 more images. This time I really tried to get more side images of Pikachu. Then I extended my training for another 5,000 epochs. And lastly, this is like a fix. I changed the detection threshold on the Android app to 0.85. And it was better. So now I have a new model, and I want to try it with something new. I was like, oh god, spoilers, really? I wanted to do something new, and the next use case was like, guess what? Videos. And I was like, you know, I want to do this on videos. Also, there was some of the recommendation that some people gave me after the first time. Like, dude, you should play a Pokemon episode and get all the Pikachus. And I was like, I think I'll do it. So I did it. Now, this is once again an example of the code. It's really similar to the previous one. However, I would like to point out 2 main differences. First, is that instead of loading one image, well, we have to load the video, of course. Then we have to iterate through every single frame of my video, and we're going to capture that frame, and then we're going to treat this frame as my image. Then, taking this frame, we're going to get all the detection, and this is going to return, well, a copy of the frame, but with the detection. Now, I have one object here called video writer. And in this video writer, you're going to feed it with all these new frames. So it's going to create a new video based on your frames with the detection. And get some popcorn, because I'm going to show an example. It's only 1 minute long. So enjoy. Pikachu likes ketchup. There we go. Oops, something wrong. What is happened? No Pikachu detected. That's awful. Old guy talking. Oops, Pikachu's bot detected. Classic. There we go. That's nice. Oh, come on. No detection. That's sad. Nothing is perfect. Ash talking. Yeah. Mitch is angry, like always. And Brock is just being Brock. But then, tan. Oh, there we go. Hey, Pikachu. How's the ketchup, buddy? Scyther wants some ketchup. Oh my god. Ketchup is broken. Whoops, mistakes. And now Pikachu is sad because he has no ketchup bottle. So, sorry, buddy. So now, results. Thank you. So, results. So in overall, the main issue here is the number of false positives, as we saw in the video. Scyther was detected. It's like, come on, Scyther is green. What's going on, TensorFlow? So for me, that was like a big letdown. Also, once again, it's that the Android app still, it feels better, but I still feel like I could do a little bit more work. So in overall, if I compare the Android with the other two, they're quite weak. I'm going to show one example there during the question, so you guys can play around if you want. But now, conclusion. In overall, I'm quite happy and pleased with the result. I mean, I have my own Pikachu detection system, even on my phone, and it is enough to impress, what is here? Your friends and other Pokemon freaks, and maybe your mom, your girlfriend, and all of you guys. Also, you know, it's been quite nice and interesting to play around this field of deep learning, just something different. And also, I'm here speaking to all of you today, which is quite cool. So for the future, I would like to keep improving my training set, maybe to use more images, so like non-frontal images of Pikachu, maybe try another configuration of my feature extractor and architecture, because the one I use is like the weakest one, because this time I wanted better performance instead of memory and speed, because I really, really wanted to have it on my phone. And I'm sure that if I try some of the most complex architecture, I'm going to get a better result, but maybe I won't be able to run it on my phone. And also, I would like to add a second class just to make it more interesting. So maybe Charmander. So that's it. Like, thanks for your time. Here I have all my info. I have my Medium blog, just in case you guys would like to know more. There I have like 2 articles describing this with every single detail. So feel free to read it. If you have any question, please ask me. A lot of people have wrote me like, hey, my model is not working. People that are having the same issue, the thing I say with Android, and I tell them the same. Do not optimize your model. So it's quite nice, really. And yeah, that's it. Credit to some of the icons I use, and thank you.
So there's plenty of time for some questions, but I'm going to steal the first one. So effectively, you are now building a Pokédex.
Kinda.
Okay.
Yeah.
Just out of curiosity, because the model for just Pikachu, how big is that?
How's big? It's really small. I think it's around 20 megabytes. I have it somewhere, but I have it on GitHub, and I know that GitHub it does not allow such big files, so it's really tiny.
But if you would like actually try to make the Pokédex first for the first 150 Pokemon,
If it's going to grow, I can't really answer that right now. I'll have to, after I build it with Charmander, then I'll send you an email like, hey, this is now the size of the model. So I'm assuming it's going to grow, but I can't really tell you by how much it's going to grow.
fair enough.
Sadness.
Let's have all the Pokemon-related questions.
Yeah. Meanwhile, I'm going to set the visor here.
You want to do a demo?
No, I mean, but while you guys ask, I just want to have this running here quickly. But yeah, feel free to ask me.
Thanks for all the Pikachus. I was going to ask about Charmander, but you also answered that. Thank you. Did your training sets also contain photos of nothing, like no Pikachus, or did you?
No, like all of them were Pikachu. Yeah. To be honest, I just wanted to make it run, so I just like focusing. Okay, this is an Pikachu. I could have tried just like to have images with no label to see if the model performs better, but I was just focusing like, nah, let's just use Pikachu and that's it.
How often does your model matches Raichus or Pichus?
Okay, Raichus, I have never seen a Raichu, but I have here an example with Pichu. If my app starts to work, so I can actually show it to you. But it actually like, with Pichus, it happens sometimes because maybe like the color palette is quite similar to the same as Pikachu, the same color. But Raichu, oh my god, it's so nerd. But Raichu is more like orangey, so maybe it does not detect it, yeah. I mean, but with Raichu, it had never happened. But with Pichu, it happens like all the time. I have here the Pichu to show you, but as always, the demo is not working now.
We have 5 minutes, so we can wait.
Okay.
But a question I suppose I have you tried just putting a picture of a yellow blob?
Yeah, and I also have it here,
Ah.
but and it does not get detected. But come on.
Okay.
Any other questions? Yeah, just feel free to ask.
There's another question.
Well, I struggle here with my.
How is the practicality of having models like that on Android phones? Because it seems I'm an Android dev, and it seems it loads a lot of battery, memory, RAM. For instance, an app is usually about 50 megabytes. It shouldn't be more than that, otherwise people starts uninstalling them. So how far are we to having actually TensorFlow as something that can actually be included in any app?
So I think that to really answer that question, I should have trained with the other architectures because, like I said, I used the weakest one, and it was okay. I don't have any issues, but I really would like to try the other one so I can make the difference. From my own experience, I can tell you that it's not like my phone gets hot or anything. No, I mean it's also like a Pixel 2, so it's quite fine. However, like I don't see any really bad improvement on the battery or the phone getting slow. Like it works the way it should be, but I cannot did it on purpose. Like I wanted to use the weakest architecture, so I'll have to try it with the most intense architecture, and then I think I will able to answer that question. Damn. Anyone else?
I think everyone's really keen on seeing a demo.
Yeah, exactly. I don't really know. So it says like it is connected, right? View.
Because, you know... Oh, there's a question?
Oh, there it is. Oh, but I'm going to get now one ad because this is my phone. Hopefully I won't get any weird notification. Jesus Lord.
Ooh, demo time.
Yeah, this is it. TensorFlow detect. So, Pikachu, right? Phone, camera. Hey! There we go, see? And now, since not everything is positive in life, then false positive. Pikachu, boo! It's not Pikachu, it's Pichu. And here, come on, man. Really? It's a bit slow, like I said, so we need some time. Nah. Oh boy. Fail. But this one is better. Yeah, more Pikachu. Hey. Woo! So see, it's fun. It's nice to have some laugh and to play around with it. So.
We have to give him like one round of applause just for that.
Anyone else?
There is one more question, and after that we will switch.
Thank you. Thank you for your talk. But I heard a lot of things about you talking about models and models, different structures. I use TensorFlow, but what exactly is the model that you use in the TensorFlow? Is deep learning or just traditional computer
Exactly.
vision
I
stuff?
knew that question was coming, so I have an appendix here. So, where's my mouse? My mouse. Yeah. Oh, come on, Juan, really? So, the feature extractor, they are actually like ConvNet. They are called convolution and feature extractor. And the one I use is called MobileNet. And it's basically just a neural network, which is going to get the features of your object. And here, this is like a screenshot from the actual specification that the default one I use. And as you can see, it talks about layers and side of layers, activation functions, and so on. So it's really just like a neural network. It's just like a fancy name. The same way we have like AlexNet and GoogleNet and so on, then we have MobileNet. And there's another one that are called like Inception. They really have like fancy names.
For the Angular version, I doubt you use this one. You said you use the weakest one.
It's this one, yeah. I mean, it's called MobileNet, like mobile, because it's quite weak in compared to the other, which are like Inception version 2, Inception version 3. So they have like more harsh name, we could say, and this is just like MobileNet. No, but really, like if you actually read the specification in the paper, you can see the big difference. Like others, they are like bigger and bigger network. They use like more rigid hyper parameters and so on. And this one is more like more relaxed, we could say.
Then we can all remember today that he was still here, not yet a millionaire, because he hasn't made the Pokédex yet. But I'm
Not yet,
sure in
exactly.
5 years from now,
But
he's going to come back and give a better demo. Juan, this was amazing. Thank you.
Thanks
Everyone
to you
just
guys.
give Juan a
Yeah.
round of applause.